let's explore a couple of functions and talk specifically about the domain. This time, we have the function itself, not the graph. Just recall, the domain is always the input. The set of numbers that makes the function defined. In other words, if I input a number, the function is able to give me, quote unquote, an answer. It always has an output. So for each number that we input, do we have an output, yes or no? Okay. So let's look at this function, x minus 4. This is a linear function. So is there anything that we have to be careful here? Notice that I can input any number and the function can always calculate the output. Of course, the number takes 4. That would be it. So that means that I can input any number here. So the domain will be all real numbers. The range, the domain will be all real numbers. Example number 2, if I have x squared minus 9, again, any number I can square it and subtract 9, no problem at all. So this function can take anything. I can produce an output very easily. Same for this one, no problem at all. Okay, so let's go ahead and, so if we have this type of function, examples of this, the domain will be all real numbers. Let's explore 3 more functions. What if I have 1 over x minus 4? What if I have x plus 2? What if I have that? Okay. Well, let's see. Now we have an issue. Why is that? Because now I have a rational, a fraction, and we know that we cannot divide by 0. So notice that I can input any number in this function except when x equals 4. Because when x equals 4, if I were to find it for 4, that will give me 1 over 4 minus 4, and that will be 1 over 0. And we still don't know how to divide by 0. So if I have the function f of x equals x minus 4, in this case, x cannot be 4. If it's 4, the function becomes undefined. So what would be the domain? If you recall, folks, if I have my real line from negative infinity to infinity, I'm going to avoid 4. So when the domain is given by negative infinity to 4 union 4 to infinity. If the function was x plus 2 over x minus 4, same thing, it doesn't matter what is the numerator, because we have to be careful with the denominator. The denominator cannot be 0. So that's their domain. I'll just write it here again. Negative infinity to 4 union 4 to infinity. And I believe we can write the rule now that if I have a rational function, we need to avoid 0 in the denominator. Okay. If you recall that, if I have a fraction, we still don't know how to divide by 0. So the domain is given by all real numbers except for the numbers that make my denominator 0. Domain given by all real numbers except the numbers that make the denominator 0. In other words, avoid 0 in the denominator. So let's look at this other example, x plus 2 over x squared minus 9. So now we know that we have to avoid 0 in the denominator. So why don't we explore making the denominator 0 to find the bad numbers? So when x squared minus 9 equals 0, I can either factor, let me factor instead of the square root method. X minus 3 times x plus 3 equals 0, difference squared. So x minus 3 equals 0, x equals 3, or x plus 3 equals 0, x equals negative 3. So these two numbers in my denominator 0. So what is the domain? all real numbers except plus or minus 3. So the domain here will be all real numbers except when x equals -3, x equals 3. In the real line, if you were to draw the real line and remove the -3 and 3, you end up with something very similar like this. Your domain would be -infinity to -3, union -3 to 3, union 3 to infinity. And the last example, again, I have the fraction. I have to avoid what, where, 0 in the denominator. So this is the denominator. Let's equal it to 0. So see what we have. X squared plus 4x equals 0. We may factor out the x. So now x equals 0 or x plus 4 equals 0. Therefore, x equals -4. So these two are the exceptions. These are the two numbers that I must remove from the domain. Therefore, we can use something very similar in this. It will be all real numbers except 0 and -4. We use such a thick marker. So the domain would be from -infinity to -4, union -4 to 0, union 0 to infinity. All real numbers except 0 and -4. Okay, so that would be one way to find the domain. Let's try something else. So I have these three examples. Again, we're looking for the domain. We're looking for the set of numbers that make the function defined. If I have the f of x equal to the square root of x minus 4, what do I need to remember? But what is still we don't know how to do. In the real world, we don't know how to find the square root of negative numbers. So we cannot afford to have negative in the radicand. Okay, so the rule, if I have a radicand, of course I'm doing the square root of the cube root or the fourth of the square root. So we know that we cannot afford to have negative numbers. So that's it. Avoid negative in radicand. This will be your rule if I have the square root. Of course, numbers can be either negative, 0, or positive. If it cannot be negative, that means that the numbers have to be either positive or 0. In other words, my radicand x minus 4 must be greater than or equal to 0. Therefore, x must be greater than or equal to 4. That's your domain. As long as I'm in the 4 or to the right, I'll be avoiding negative in the radicand. So we'll be safe as long as we are at the interval 4 inclusive, comma, infinity. From 4 to the right, I'm safe. Left of 4, I'm in big trouble because the radicand then will become negative. Okay, so now we know this is very straightforward. My radicand 7x plus 9 must be greater than or equal to 0. We cannot afford to have negative in the radicand. Subtract 9, divide by 7. So 7x plus 9 greater than or equal to 0. Therefore, 7x greater than or equal to -9, or x greater than or equal to -9, 7 divided by 7, or -9, 7, comma, infinity. That will be your domain in interval notation. Last but not least, again, avoid negative in the radicand. So I'm doing the red, so 3x. So therefore, what do I have here? -3x plus 15 must be greater than or equal to 0. -3x must be greater than or equal to -15. We subtract, what did we do? We subtracted 15, so -15, and now we divide by -3. Divide by -3, the sign changes, so it'll be less than or equal to It's negative 15 over negative 3, 5. In other words, this function is, we are safe with this function as long as my input is from 5 to the left. Okay, so that would be good. So if so this is the same thing as negative infinity to 5 bracket. So if I have, this is 0, this is 5. So if I input 5 here, 5 times negative 3, negative 15 plus 15, that's 0. Let's say that I input 2. It's here. 2 is a good number in this case. 3 times negative 2, that would be negative 6. 15 minus 6, 9. The square root of 9 is 3. So as long as I'm in this world, I'm safe. Okay, so if I do, whatever number, as long as I'm in this case, I'm fine. If I take negative 10, so that would be negative 10 times negative 3, that's positive 30 plus 15, 45. So that would be a good number, square root of 45. Now, what if I input 10? Now I'm on the right. 3 times negative 10, that would be negative 30 plus 15, negative 15. So I'm in trouble here. So as long as I'm to the left of 5, I'm safe. That's it. That's the domain. So just to summarize, let me see if I can summarize without pausing this. So for now, for this chapter, we explore very quickly 3 types of functions. Without calling them, I have if f of x is a polynomial, namely I don't have fractions, I don't have the square root, nothing, the domain would be real numbers. If the function f of x is rational, we need to avoid 0 in the denominator. And if the function is a radical square root, we need to avoid negative in radical. Okay, so those are your 3 rules, or the basic rules. Go through it in kind of a sloppy, but I hope you follow. Thank you so much. Have a good one.